consider the states of matter and the changes that we can have going from one state to another. Now notice the order that I've put these in. I've got the solid at the bottom, and maybe this kind of feels right, this order, because gases float. You might think of it that way. At the bottom I have the solid because the molecules are really packed tightly, and then a liquid, they're a little further apart, and of course a gas, they're really far apart. Anyway, having them in this order can kind of help you answer some of the questions about energy and if it's absorbed or released. So I'm going to start by writing up arrows. And so as we do, we'll name these. Going from a solid to a liquid is melting. Okay, and then going from a liquid to a gas is vaporization. Of course, vaporization is the same as how do I want to say this? Evaporation and boiling are forms of vaporization, so it could be boiling. Okay, and then we also have the possibility of going directly from a solid to a gas, and that is sublimation. Okay, let's go on the other side. Let's do the down arrows. So a gas to a liquid, that's condensation. And then from a liquid to a solid, that's freezing. And then from a gas to a solid, that's called deposition. And one other one I'm going to add in on this other side is that a fancy word for melting is fusion. Okay, so I did the ups on one side and the downs on the others. Let's talk about the ups. If you think about it, what do you do to something if you have a solid and you want it to be a liquid? You add heat, don't you? Okay, and what if you have a liquid and you want it to become a gas? You add heat. If you have a solid and you want to get it to sublime or undergo sublimation, not all substances will do that without melting, but some will go directly, and naphthalene is one of them. But anyway, to get a solid to become a gas, you heat it. So that's why I put all of these in red. In these, you heat them to make them happen. You apply heat, and that's because the substance absorbs heat. When these changes occur, when ice absorbs heat, it becomes liquid water, so on. Okay, so these are pretty intuitive. It's the opposite that seem a little strange at times, and let's explain that. So these are the ones that you cool them to make it happen. But cool means that the substance is releasing heat. Okay, and that might seem a little strange, and I say cool because cooling something means you're removing heat from it. Think of liquid water in your freezer. In order for it to freeze, you cool it, don't you? Just like we said up here. But what that means is that cooling means removing heat. In other words, the liquid water is releasing heat, giving it up to become a solid. And that might seem really strange because your freezer doesn't get hot, your refrigerator doesn't get hot. What's happening though is that your freezer is removing heat from the liquid and putting that heat out into the room. And that's how your refrigerator works. It removes heat out of the things inside and dumps it out into the room. Okay, so that is a process where the liquid water is releasing heat to become a solid. So these are a little harder to see because nothing's getting cold a lot of times. Or nothing's getting hot. We think of these as the things that occur when something cools. Like if you cool gas, it may condense, like water vapor may condense into a liquid. But what we're really doing is removing heat from the gas. In other words, the gas form of water is releasing heat so that it can become a liquid. Anyway, these I have to really, it's easy to get these backwards, and I have to really think about, especially these on this side. These are pretty easy to remember. If you remember that you heat things to make that happen, these work. The substance is absorbing heat, and just know these are the opposite. Or if you want to, these are the things that you would cool something to make them happen.